In this lab, we're going to learn about frequency distributions. Here's the problem. A behavioral scientist is studying the effects of stressful life events on life satisfaction. So when things go wrong, how does it affect how satisfied someone is with their life? He conducts a correlational study in which participants fill out an online survey. One survey item reads, "I am satisfied with my life." So chances are this is coming from a life satisfaction scale. There are multiple survey items that are summed or averaged together to create a final score. This is only one of those items. So for simplicity, we're going to be working with a single item in this lab. Participants responded to this item on a scale of 1 to 7. So they probably responded strongly disagree, somewhat disagree, disagree, neither disagree nor agree, so forth. But they've been coded from 1 to 7. So strongly disagree is a 1, strongly agree is a 7. A random sample of 30 participants is provided below. So down here we have 30 different people. Each number is a score on this particular item from a different person. So the 6 represents a single person who answered 6. So they are agreeing with the statement, "I'm satisfied with my life." Over here is a 1. This individual strongly disagreed with the statement. They were not satisfied with their life. So the goal of this analysis is to examine the frequency distribution of these data in order to draw meaningful conclusions about this sample. Okay, very good. So we're going to begin by creating a frequency distribution table. We're going to create a table for all 30 scores, which includes frequencies, relative frequencies, and percentages. Over here in the first column are each of the 7 possible responses. So each of the 30 people gave us one of these 7 responses. In the next column, we're going to give the frequency. That's how many people gave this response. So for example, in the first row, how many people said 1, strongly disagree? Relative frequency is a proportion of the people who gave that response, the frequency, to the total number of people. So you take this cell and divide by 30 because there are 30 people, and then we convert that to a percentage for the final column. So let's go ahead and take a look. So first we want to know how many people answered 1. They strongly disagreed with the statement. So in order to do this, we're going to go up here and go ahead, and what we're going to do is we're going to check off so we can not lose track of all the people who answered each response. So we're looking for all the 1s. So of course here's a 1 right here. So I'm going to check that one off and take a look. And it appears that there is only one 1. So we'll come down here, and in the frequency cell we will put a 1. Okay. Now let's go back. We need to find how many people answered 2. So I'm going to just go along here looking for all the 2s. Don't see any on the first. Don't see any on the first row. Over here we have a 2, 1, 2. So 2 people answering 2. So go down here, and in the next cell we're going to put a number 2. There we go. Move on to 3. So how many people answered 3? Let's take a look. Okay, 1, 2. Down to the next row, and 3. Looks like there are 3 3s. So of course we'll come down here and we'll draw a 3. Okay, now we're looking for how many people answered 4. So you have 1, 2, 3. Next line. Looks like there are only 3 4s as well. So put another 3 down here. Moving to 5, you should be getting the pattern by now. 1, 2, 3, 4, 5, 6, 7. Quite a few more of these. So there were 7 people who answered with a 5. Moving to the 6s. 1, 2, 3, 4, 5, 6, 7, 8. Very common response. So go down here and put our 8. And then finally 7. How many people strongly agreed with this statement? 1, 2, 3. Oh, that was 3, 4, 5, and 6. And we'll come down here and put 6. There we go. So now we have the first row, the first column in our frequency distribution table. We have the frequencies, how many people gave each response, and if we were to add these up, this should add up to 30. Okay, the next column is the relative frequency. Now the relative frequency is the proportion of the frequency to the sample size, which is 30. So what we have to do is take each of the frequency values, divide by 30, and represent that as a decimal. So I have our calculator up on the screen to show you how simple this is. So we first take 1, because we have one respondent who gave us a 1, strongly disagree, divide by 30. That gives us 0.03. So we're going to be rounding to the hundreds place here. So we have 0.03. So 0.03 is the relative frequency for the number 1 rating. All right, we'll go back over here. Now we're going to divide 2 by 30. That's going to give us 0.06 repeating. So we're going to round this to 0.07. So we'll go over here, 0.07, just like that. So we rounded 0.066 to 0.07. Next we have 3. The 3 divided by 30 is of course 0.1. So we'll come over here and we're going to put, now we're right into the hundreds place, so we're going to add a 0. So 0.10. 3 again, so of course that's going to stay the same, so another 0.10. There we go. Now we have a 7, and we're going to divide 7 by 30. Let's try that again. 7 by 30, which is going to give us a 0.23 repeating, so we'll round that to 0.23. All right. And then we have 8 divided by 7. So 8 divided by 30, excuse me, 8 divided by 30 gives us 0.26 repeating. So we'll round that to 0.27. All right, 0.27. And then finally we have a 6. So that's going to be 6 divided by 30, 0.2. And we'll add the second decimal place. So 0.20. All right, so now we have the frequency and we have the relative frequency. Now the final thing we want to include is the last column, which is the percentage. And so we just need to convert from a relative frequency or a decimal to a percentage. So to convert a decimal to a percentage is very easy. All you have to do is move the decimal place 2 places to the right and add a percent sign. Okay, so in the first one we have 0.03. We move the decimal places over twice. So that's going to be 3%. Okay, same thing with the 07. So we move it 2 places to the right. So that's going to be 7%, like that. Now we have 0.10, 2 places to the right. This is going to be 10%. We have another 10% right below it, like so. 0.23 becomes 23%. Again, moving the decimal 2 places to the right. Then we have 0.27, which becomes 27%. And finally 0.20, which becomes 20%. So now we've completed our frequency distribution table, where we have the rating. We have how many people, right? The frequency gave that response, the relative frequency, which is the proportion of the frequency to the total sample size, and then the percentage. So we can see here the largest percentage, 27%, was a satisfaction rating of 6. So that was the most common percentage. But in order to help us get a visual sense for what this distribution looks like, we're going to move on to the next section and create a relative frequency histogram. like so. We're going to essentially chart these responses to get a sense for what the distribution looks like. So we can get rid of this and go ahead and enlarge our screen here. Okay, so each column now is a different satisfaction rating. So on the x-axis is life satisfaction rating 1 through 7. And then on the y-axis is the relative frequency. It goes up to 0.3 because our largest relative frequency was 0.27. So we don't really need to go much past that. So 0.30 is here. So we're going to create a chart of the frequencies called a relative frequency histogram. Okay, so first thing we need to do is start with the first column. So we have a 1. How many people, or I should say not how many people, what is the relative frequency of respondents who gave a 1.03? So it's definitely on the smaller side. So what we're going to do is create a little box here, our first part of our graph. So let's see here. So here's 5. It's less than 5. The halfway point, 0.25, would be here. So it'll be just a little bit past the halfway point, right about there. Okay, so this is the first bar in our relative frequency histogram. 0.03 people. I'm sorry, relative frequency of 0.03, which was one person out of 30, giving us that response. Now, what about the 2's? Relative frequency for the life satisfaction rating of 2 is 0.07. So we'll go down here and we will create another bar. And we want to go to 0.07. So it's going to be a little over, see 5, 6, 7, 8, so a little less than halfway up the next one here, right? Because here's 0.10, here's 0.5, 0.75 would be here, so just a little bit below. Okay, so that's for 2. Moving on to 3, relative frequency of 0.10. That'll be a little easier to graph. All right, so we'll go down here and right up to the line, which is 0.10. Perfect. Number 4, relative frequency also of 0.10. So we're going to create another one just like that. It should be exactly the same height. And then we're going to have 5, relative frequency of 0.23. So it's going to jump up a bit right up here. So here's 0.2, and that's going to be a little more than halfway. So we'll put that right about there. It's okay if your graph isn't exactly, if your histogram isn't exactly perfect. 0.27 will be next. So come down here, and 5, a little less than halfway between these two, right about there. And then finally we have relative frequency of 0.20 for the last column. So we'll go down here and we'll drop it right on that line. So here is a relative frequency histogram of the distribution. What we like to do sometimes is to come in here and sort of draw in or color in the bars like this. There we go. So you can color these in on yours as well. There we go. Okay. Couple more to go. And there we go. That's very nice. So there is our relative frequency histogram. And now, in the last section, we're going to draw meaningful conclusions about the sample. What can we say about the sample based on the frequency distribution? So these are the responses to the single item. I am satisfied with my life. Strongly disagree is down here with the 1. Strongly agree is up here. Neither agree nor disagree. So the halfway point would be the 4. So over here are the people that are on the disagree side. These are the people on the agree side. So what can we say about this? Well, the first thing I would notice is that this is a skewed distribution. So a normal distribution would be the highest in the middle, right around a 4, and then it would drop down on the right side. So normal distribution would look something like this. So it would come up at the 4s, and then drop down on this side, right? So this is closer to a normal curve, but that's not what we have here, right? We have it low on the left and high up on the right. So here we have what's called a skewed distribution. A skewed distribution is exactly what we have here. We have a long tail on one side and them all bunched up on the other side. This is called skewed left. So people get a little bit confused when we talk about skews because they see the large grouping and they want to call that the skew. Oh, this is skewed right, or there's a large high skew. But that's not what's going on. The skew refers to the tail. So this is skewed left. So I would go ahead and begin with that. So let's talk about the skew of the distribution. So the distribution has a negative skew. So another way of talking about skewed left is to say it has a negative skew. If it were low on this end, the tail were on the right, it would be a positive skew. So the distribution has a negative skew. And what does that mean? Meaning that most of the participants agreed with the statement. And what was the statement we're talking about? I am satisfied with my life. There we go. Whereas very few, let's say that relatively few, whereas relatively few disagreed with this statement. This means that most of the participants in this sample experienced high life satisfaction. There we go. So most of the participants experienced high life satisfaction, not very many in the middle, and certainly not very many on the low end. So this is probably not a clinical sample. This might be what a population sample would look like. If we were dealing with highly depressed people in a clinical setting, perhaps the distribution would look different. Perhaps it would be the other way around. People are depressed and they have a low level of satisfaction. Maybe then there's a positive skew at that point. But this is basically what we can say about this distribution, negative skew. Most of them agree with the statement, experiencing a high level of life satisfaction. So this is how you create a relative frequency histogram, how you create a frequency distribution table, and how we would interpret those data. Hopefully that is helpful to you. Thank you.